Good day, students. This is Mr. Mfona, your math teacher. Today we're going to be talking about trigonometric functions in right triangles. So by the end of this lesson, you should be able to use a right triangle to find values of trigonometric functions for acute angles. And the vocabulary words that we will learn during this lesson will be trigonometry, adjacent side, opposite side, trigonometric ratios, sine, cosine, tangent, cosecant, secant, and cotangent. So you can pause this video at this point and then take down your notes. And we'll move on to the next slide. So what is trigonometry? It says, read the passage below and answer the questions. Definition of trigonometry. Trigonometry is the study of the relationship among the angles and sides of a right triangle. A right triangle is a triangle that has a right angle. A right angle is an angle whose measure is 90 degrees. Angles are identified by a symbol, say theta or alpha, or by the letter at the vertex where the angle is located. There are 6 different trigonometric ratios depending on the ratios of the sides of a right triangle. The trig ratios are sine, abbreviated SIN, which we just call sine, cosine, abbreviated cos, tangent, abbreviated tan, cosecant, abbreviated CSC, secant, abbreviated sec, and cotangent, abbreviated cot. So let's go ahead now and use this information here and fill in the blank. It says trigonometry is the study of the relationship among the blank and blank of right triangles. So if you see there, that was amongst what? The angles and sides, right? So we have angles and sides. Trigonometry is the study of the relationship among the angles and sides of a right triangle. Next, a right triangle is a triangle that has a right angle, of course. Has a right angle. A right angle is an angle whose measure is 90 degrees. So you type your 90. To get the degrees, you hold down the control key and press dot. Then type your 0. That's how you get the degree. There are blank trigonometric ratios. There are 6 of them. So there are 6 trigonometric ratios. Give the abbreviation for each of the following trig ratios. So we have sine is abbreviated SIN. Some people say sin, some people say sine. So I will just say sine, right? Cosine is abbreviated COS, which is cos. Tangent is abbreviated TAN, which is tan. Cosecant is abbreviated CSC. Secant is abbreviated SEC, which I'll say sec. And cotangent is abbreviated COT, which is cot. So go ahead and pause the video at this point and take down your notes. When we'll move on to the next slide, which actually defines the sides of a right triangle. All right, we have in a right triangle, the 2 sides that form the right angle are called the legs. This is very important. Okay, you look at the sides that form the right angle. This side and this side. These are the legs. The legs can either be the adjacent or the opposite side. Now, the hypotenuse. This is so important. How do you identify the hypotenuse of any right triangle? First, the hypotenuse is the longest side. it is the side that does not touch the right angle. You see, the right angle is formed by the legs. The hypotenuse does not touch the right angles. Or you can say it's the side that is opposite the right angle. So that's how you easily figure out the hypotenuse, the side that does not touch the right angle at all. Okay, now in reference to our angle here is theta. This side here that actually passes through the angle, that combines with the hypotenuse to form the angle and passes through that right angle, is the adjacent side. So the adjacent side must touch the angle. Okay, your adjacent side must touch your angle of reference. Then this side, if you draw like a straight line from that angle of reference straight across, you would hit the opposite side. So from here, that's the opposite side there. You see, the opposite side has nothing to do with this angle. Okay, so that's your opposite side. That's how you identify the sides. Now let's look at these examples here. It says, for each right triangle, identify the hypotenuse, the opposite leg, and the adjacent leg to indicate, to the indicated angle. All right, the first one, this is the indicated angle. The very first thing to identify is the hypotenuse. That's your right angle there. It is formed by these two legs. So the hypotenuse clearly is this one, which is C. All right. Now, the adjacent side or the adjacent leg is the leg that combines with the angle, with the hypotenuse to form the angle. So the adjacent side, adjacent in English means what? Side by side, close to. So this would be your adjacent side, A. And then, of course, the opposite side is opposite this angle. So your opposite side would be B. All right, so again, your hypotenuse, if I start with the hypotenuse, we saw that the hypotenuse was C. Then the adjacent side is A, and the opposite side is B. Now let's go to look at the next one. This is our angle of reference. Okay. Again, the hypotenuse is always the easiest one. That's your right angle there. The hypotenuse has nothing to do with the right angle. Okay, so it will be this side here. That's your hypotenuse there, which is K. Then the side that actually touches this angle, that combines with the hypotenuse to form the angle, that's your adjacent side. So your adjacent side here would be L. And then, of course, the side opposite the angle is your opposite leg, which is J, that side. So again, our hypotenuse is K. Then the adjacent leg or adjacent side is L. And then the opposite side is J. All right, so make sure you understand how to identify these sides. Okay, now for this example, this is our angle of reference. And if you look the way the letters are written, you see, if you look up here, this L was in the middle, which means it's all of this side. But the way these letters are written, they're written at the vertex. So you, in order to read a particular side, you need the letters at the end of that side. Okay, clearly this is our hypotenuse. Has nothing to do with the right angle. So our hypotenuse is HU. Okay, now the adjacent side, the side that touches this angle, the side that combines with the hypotenuse to form this angle here, and also goes through the right angle. So it will be this side here, which is HI. Your hypotenuse was HU. So this is your adjacent side, which is HI. And so clearly, this would be your opposite side, which we can call IU. So the hypotenuse is HU. You can also say it is UH, it's the same thing. The adjacent leg or adjacent side is HI. or we also say IH. They're the same. Remember how to name segments. All right, the opposite side is IU, so you can say IU or UI. Okay, so that's how you identify the sides of a right triangle. Again, this is so very important because this is the core of trigonometry, for you to be able to identify the three sides of any right triangle correctly. All right, go ahead and pause the video at this point and take down your notes, and we'll look at the next slide. So now we'll actually take a look at the definition of the 6 trigonometric ratios. We'll take the first 3. So again, just remember that in a right triangle, if this is your angle of reference, then your hypotenuse is this side here that has nothing to do with the right angle, okay? The side opposite the right angle. The adjacent leg is in reference to this angle here, is the angle that combines with the hypotenuse to the side that combines with the hypotenuse to form that angle. So it's actually the side that touches your angle of reference and also passes through the right angle. And then, of course, this is the opposite side, the side that has nothing to do with your angle. All right, we said that sin theta was abbreviated SIN, which I'll just call sin theta. Some people say sin theta. Cosine of theta is abbreviated cos theta. Tangent of theta is abbreviated tan theta. By definition, sin theta is the opposite side or the opposite leg over the hypotenuse. So if you know the length of the opposite leg and the hypotenuse, then you know the sine of the angle. While cos theta, by definition, is the adjacent side over the hypotenuse. And by definition, tan theta is the opposite side over the hypotenuse. We can also define tan theta as sin theta over cos theta. So again, you have to figure out a way to memorize these definitions. They're very important. Okay, for me, I just know that, for instance, for sin theta and cos theta, they all have hypotenuse at the denominator. So I just concentrate on the numerator. I know that sine goes with opposite. Every time I hear the word sine, I always think about opposite. Sine goes with opposite. And then if sine goes with opposite, cosine automatically goes with adjacent. And then tangent goes with both opposite and over adjacent, okay, both of them. You can also use this acronym here, SOHCAHTOA. You see that? So, S-O-H. Sine is opposite over hypotenuse. Ka. Cosine is adjacent over hypotenuse. Toa. Tangent is opposite over adjacent. All right, let's look at these examples. So it says, consider the right triangle below. Okay. Now this is our angle of reference. So let's identify our sides. So first, this is your hypotenuse, the side that has nothing to do with the right angle, right? That's your hypotenuse. Then your adjacent side would be this side here that actually touches the angle and goes through the right angle. So this is your adjacent side, 10 root 2. And then, of course, the 5 would be your opposite side. So that's how you identify your sides. So now let's look at our trig ratios. Sin theta. Again, remember, by definition, sin theta is what? If you look at here, SOHCAHTOA. Sine is opposite over hypotenuse. So sin theta, by definition, is opposite over hypotenuse. I'll just write it here just to guide you, but you don't need to write that down. And what is our opposite side? Our opposite side is 5, and the hypotenuse is 15. So that will be 5 over 15. But you cannot leave your answer as 5 over 15. So because 5 can go into 15. 5 goes into 5 one time. One time. 5 goes into 15 three times. So that will be 1/3. Now let's look at cos theta. Cos theta, by definition, if you look at your SOHCAHTOA, the CAH, cosine is what? Adjacent over hypotenuse. So cos theta would be adjacent over hypotenuse, right? And in this example, our adjacent was what? 10 root 2. So that will be 10 root 2. I already have this square root here. Or you go and take insert to put the square root. So I'll just copy that there and paste it over here. So we have 10 root. Remember, to copy is Control C. To paste, Control V. 10 root 2. Okay. Now that line there is broken. It's because of the underline. So all you do is just highlight it and you click underline. Or you do Control U to underline it. And you see it comes back. The line comes back. All right. So that's adjacent of a hypotenuse. Our hypotenuse is what? 15. Okay. 5 can go into 10 and 15, so that will give us 5 goes into 10 two times. So we have 2 root 2, Control V to paste that square root 2. Now let's highlight that and underline it. So we highlight that and then you press Control U to underline. Okay. So then at the bottom we had 5 goes into 15 three times. So that will be 2 root 2 over 3. Now let's look at tan theta. Again, if you look at SOHCAHTOA, tangent is what? Opposite over adjacent. So tangent is opposite over adjacent. So the opposite is 5. So have 5 over, the adjacent is 10 root 2. So you have 10. I paste my square root, Control V, and then root 2. All right. We see here again that 5 is common. 5 can go into 10. So 5 goes into 5 one time. And 5 goes into 10 two times. So we have 2 root 2 at the bottom there. Control V, and then 2. Now, I want you to pay attention to this. Generally, in mathematics, you cannot leave your answer with a square root at the denominator. Okay? When you have a square root at the denominator, that fraction is not in its simplest form. So you have to do what we call rationalization of the denominator to simplify it. So what you do is you just multiply the numerator and the denominator by that same square root. So here we're going to multiply the numerator by the square root of 2, and then we would also multiply the denominator by the square root of 2. So multiply numerator and denominator by that square root. Okay, now at the numerator, 1 times square root of 2 will just be square root of 2. So we have Control V, square root of 2. Highlight that and underline it. Control U to underline. Okay, while at the denominator, we have these two outside here. So we'll type that. Then square root of 2 times square root of 2 is just 2. Okay, so the square root of 2 times the square root of 2 is just 2. Square root of something times that same square root is just that thing. It's like square root of 7 times square root of 7 is 7. Square root of 20 times square root of 20 is 20. Square root of 87 times square root of 87 is 87. So this will just be 2 times 2. Right? And now that will simplify to we have our root 2 at the top there. So root 2, remember to complete that fraction bar, just highlight and underline, Control U. Then at the bottom, 2 times 2 will be what? 4. So that will be, this is now in its simplest form. You see, the square root is no longer at the denominator. So again, remember, this process is called rationalization of the denominator. Go ahead and pause the video at this point and take down your notes, and we'll take a look at the last slide. All right, in this slide, we'll actually go ahead to define the remaining 3 trig ratios. So remember, we said cosecant is abbreviated by CSC, right? Cosecant, we abbreviate that by CSC. Secant is abbreviated by sec theta. Cotangent of theta is abbreviated by cot theta. By definition, cosecant of theta is 1 over sine theta. But remember that sine theta was what? Opposite over hypotenuse. So 1 over sine theta simply means you flip the definition of sine theta, which we know is opposite over hypotenuse. So we're going to flip it, and now we'll have hypotenuse over opposite. Okay. Now for sec theta by definition is 1 over cos theta. So we know that cos theta is what? Adjacent over hypotenuse. So 1 over means you flip it around. So we'll have hypotenuse over adjacent. And then similarly, cot theta by definition is 1 over tan theta. And we know that tan theta is opposite over adjacent. So 1 over that means you flip it around, and then we'll have adjacent over opposite. And if you go by the definition of sine and cos, then it will be cos theta over sine theta. So again, you have to figure out how to memorize these trig ratios, okay? So again, remember, cosecant of theta is 1 over sine, secant of theta is 1 over cos, and cot theta is 1 over tan. At least cot theta is easy because cot and tangent go together. Students generally get confused with cosecant and secant, so figure out how to memorize those. All right, let's look at this last example. It says, consider the right triangle below. Again, let's identify our sides. That's our angle of reference there. The first and easy side to identify is your hypotenuse. That's your right angle there. The hypotenuse has nothing to do with the right angle, so this will be the hypotenuse, 17. The adjacent side will be this side here that touches the angle of reference and goes through the right angle. So our adjacent side is 8. And then, of course, the opposite side would be 15. So let's use that now to answer this question. All right, so we're asked to find cosecant of P. We know by definition, cosecant is what? 1 over sine, and sine is opposite over hypotenuse, so 1 over sine will be hypotenuse over opposite. Our hypotenuse is 17, and the opposite is 15. Now let's look at sec P. Okay, so sec P, that's secant. By definition, sec P is what? 1 over cos P. And we know that cos is adjacent over hypotenuse, so 1 over that will be hypotenuse over adjacent. The hypotenuse is 17, the adjacent is 8. So it's 17 over 8. Lastly, cot P, by definition, is 1 over tangent. And we know tangent is opposite over adjacent, so 1 over that, we flip it, we have adjacent over opposite. The adjacent is 8, and the opposite is 15. All right, so go ahead and pause the video at this point and take down your notes, and that will be it for today.